Okay, so I put a little note in there that says the main thing that you need to remember, if it can be written as a fraction without an irrational number, then it is rational. So if you look up here at this example right here where it says the square root of 26 over 3, well, the square root of 26 is not rational because it's not a perfect square. Even though it's written as a fraction, it is irrational because it has a irrational number in it. All right, so now we're going to do some practice, and I'm going to need to fit the page so that I can do so, and I'm going to try to drag them to where they're supposed to go. So this is your assessment, okay? I've given you the number 3, so I'm going to copy and paste that because I want you guys to do it, but I'm going to give the example differently. So I'm using this 4. 4 is a counting number, so I'm going to take that, I'm going to drag it over to the natural numbers because that's where it goes to, well, hopefully going to. You need to have it look like a crosshair. There we go. Drag it over here. It is a counting number, which means it's a natural number. I count naturally. Now let's do the example of pi. So I will again try to select. And instead of it being pi, I'm going to say pi over 2. Well, it's written as a fraction, so that means it's rational, but it has pi in it, and pi is irrational. So that means I have to drag that one to the irrational system because pi is irrational. I have this one, negative 125 thousandths. So I'm going to make a copy and paste of that one, and I'm going to change it to a 5. 0.525, 525 thousandths. That one is a terminating decimal, so it ends. So it is irrational. It's not a whole number, so it's just a decimal, but I could write it as a fraction. Negative 7. We're going to do a copy with that one. Instead of negative 7, I'm going to make it negative 17. Well, negative 17 is a normal number. It's not a fraction. So, but it is also not a whole number, 0, 1, 2, 3. It's a opposite. So it goes there. Square root of 25. I will practice it. Instead of it being the square root of 25, I'm going to make it the square root of 36. Well, 36 is a perfect square, so that means it's really 6, but it's up here. Square root of 36 goes up there. It's a rational number. What's the other examples? Let's do this one down here. Instead of it being 3.12, 12, you hear me repeating. I'm going to make it 4.12. See how that's repeating? So my rule down here says decimals must be terminating or repeating. So even though it goes on forever and ever, it's repeating. So it is a rational number. This one, 4.832, but it has the ... at the end. So instead of 4.832, let's put 7.832, ... So it goes on forever. That means, does it terminate? Does it end? No, those ... means it doesn't end. So I have to drag that up there. I don't think I've done this one. I don't think I've done this one. So the square root of 26, we use the square root of 36. So I'm going to use the square root of 37. Is that a perfect square? No, it is not. So I have to drag it up here. So what is your expectations? I have now shown you how to do this. You will have an assignment on Google Classroom that asks you to sort these numbers and turn that in. These notes are there for you to refer back to if you need them, but you do not need to drag on this page. You need to drag on the other page.